There's a creature in the ocean that can throw a punch faster than a bullet leaves a gun. Its strike creates temperatures hotter than the surface of the sun, and it can see colors you will never imagine. Evolution gave it weapons that should destroy its own body. So why is it still alive? The coral reef is a war zone. Hundreds of species fight for the same square meter of rock. Food is scarce, hiding spots are limited, and everything wants to eat you. To survive here, you need an edge. The mantis shrimp didn't just get an edge, it got a hydraulic weapon system. Let's strip this animal down to its engineering. On the surface, it looks almost peaceful. Bright colors, segmented body, alien eyes that track independently. But buried in its front appendages is something evolution doesn't usually create: a spring-loaded hammer. These are called raptorial clubs, and they are biological mistakes that somehow work. Here's the physics problem. To generate enough force to crack open a clamshell, you need speed, explosive speed. But in water, speed requires energy most animals don't have. Evolution's solution? A saddle-shaped spring. This spring is made of compressed chitin, the same material as insect exoskeletons. The mantis shrimp loads it like a crossbow, slowly, patiently. And when the latch releases, the club accelerates at 10,000 times the force of gravity. In 2.7 milliseconds, it reaches 50 miles per hour, underwater. That's faster than a .22 caliber bullet, but speed is only half the weapon. When the club strikes, it moves so fast it creates a vacuum behind it. Water can't fill the space quickly enough, so a bubble forms, and when that bubble collapses, it releases a shock wave, a second strike, for free. This cavitation bubble reaches temperatures of 8,500 degrees Fahrenheit, as hot as the surface of the sun. The prey doesn't just get hit, it gets flashbanged. Let's run the numbers. Burst power, 10 out of 10. This is one of the most violent strikes in the animal kingdom relative to size. Strike speed, 10 out of 10. 50 miles per hour in water is physics-defying. Precision, 8 out of 10. Those independently moving eyes track prey with terrifying accuracy. Armor penetration, 9 out of 10. Can shatter crab shells, aquarium glass, and human fingers with equal ease. But here's where the design starts to fail. Durability, 3 out of 10. That club, it's a ticking bomb. Every strike creates microfractures. The forces are so extreme, the club should shatter on impact. And sometimes it does. Evolution's solution? The mantis shrimp molts. Every few months, it sheds its entire exoskeleton and grows a new one, a fresh club, unbroken. But molting leaves it vulnerable, soft, defenseless. It has to hide for days while its new armor hardens. This is the cost of power. Energy cost, 2 out of 10. That spring-loaded mechanism is metabolically expensive to grow, expensive to maintain, expensive to use. A mantis shrimp that misses wastes massive amounts of energy for nothing. And if it's hunting in the open ocean where prey is scarce, it starves. Maneuverability, 4 out of 10. Those clubs are heavy. Front-loaded weight distribution means it's not built for chasing. In open water against fast swimmers, it loses every time. Evolution didn't build a perfect hunter. It built an ambush assassin that can only win in one scenario: close quarters, hard targets, one strike. So how does it actually hunt? Patience. The mantis shrimp waits, sometimes for hours, hidden in its burrow with only its eyes exposed. Those eyes, they're the most advanced visual system on Earth. Humans see 3 primary colors. The mantis shrimp sees 12. It can detect polarized light, UV light, circular polarized light, wavelengths we didn't even know existed until we studied this animal. It's not just seeing prey, it's reading the reef and dimensions we can't comprehend. When a crab gets close, the mantis shrimp doesn't chase. It explodes from cover. One strike, the crab's shell shatters, and it's over before the nervous system registers pain. But the thing nobody talks about? Those eyes, they come with a cost too. The mantis shrimp's brain can't process all that visual information. Humans have complex visual cortexes that interpret color combinations. We can see millions of shades. The mantis shrimp? Its brain is simpler. It sees 12 channels, but it doesn't blend them. It sees more wavelength than us, but fewer overall colors. Evolution gave it a sensor array so advanced that its own brain can't fully use it. It's like having a supercomputer with dial-up internet. The hardware is incredible, the software never caught up. And in the reef, that limitation is lethal. Octopuses hunt mantis shrimp. They're smarter, more flexible, and they don't need to land a perfect strike. They just wait. Wait for the mantis shrimp to commit to a punch. And when those clubs are spent, trapped in the follow-through motion, the octopus strikes. No weapon in nature is unbeatable. Every advantage has a counter. The mantis shrimp is not a perfect organism. It's a collection of compromises. Eyes that see the impossible but can't interpret it all. Weapons that defy physics but break under their own power. A body built to dominate but only in one specific scenario. Evolution doesn't create gods, it creates specialists. And in the narrow corridor where the mantis shrimp was designed to fight, nothing survives the strike. Speed has a cost, vision has a cost, power has a cost, and evolution always collects.